Hello everyone, we the students of Pro from CSC department have done a project on knowledge discovery using particle swarm optimization. Under the guidance of Dr. A. Sai Hanuman, we are a team of 4 members: A. Shravani, K. Lakshmipriya, Neetu Kumari and Y. Shibarani. Contents: Introduction to data clustering, K-means algorithm and flowchart, advantages, disadvantages of K-means, introduction to optimization, introduction of PSO and its fundamentals, PSO clustering algorithm and flowchart, advantages and applications, and conclusion. Data clustering. Data clustering is grouping a set of data vectors into number of clusters or bins such that the elements or data vectors within the same cluster are similar to one another and are dissimilar to the data cluster elements belonging to another clusters. Framework for data clustering. Clustering algorithms can be grouped into two types: supervised and unsupervised. Supervised. In this, the learning algorithm has an external teacher that indicates the target class to which the data vector should belong. Unsupervised. For this type, a teacher does not exist and data vectors are grouped based on the distance from one another. Requirements. Software requirements. A new version of Java software, Windows operating system. Hardware requirements: RAM of 1 GB and hard disk of 512 MB. Introduction to K-means algorithm. Knowledge discovery and data mining methods have been applied to discover hidden patterns and relations in complex datasets, where clustering is one of the most important approaches used for this purpose. There exist a number of algorithms for clustering, where K-means algorithm is commonly used and is significantly sensitive for selection of centroids. K-means clustering algorithm. It is a partitional-based clustering algorithm aims at assigning each pattern of a given dataset to the cluster having the nearest centroid. Uses similarity measure to determine the closeness of two patterns. Similarity can be measured using Euclidean distance or Manhattan distance or Minkowski distance, or maybe another one like Mahalanobis distance. Iterative process where final results depends upon the values selected for initial centroids. Datasets. There are many multidimensional datasets. Some of them are iris dataset, breast cancer dataset, wine dataset, etc. Here we can see the screenshot of iris dataset. There are 5 values in a row. The first 4 values are the integer values which represent petal length, petal width, sepal width, and the last string represents the class of the flower. This is a flower iris dataset, so we'll have the sepal length, sepal width, petal width, and the class of the flower. The class may be Iris setosa, Iris persica, or Iris virginica. Algorithm for K-means is as follows. Initialize randomly NK cluster centroid vectors. Repeat, assign each data vector to the chosen centroid vector. The distance from the data vector to centroid vector is determined using the equation, Euclidean distance equation, where distance between two is the x and y is root over x1 minus x2 whole square plus y1 minus y2 whole square. Recalculate the cluster centroid vectors and the number of data vectors in the cluster. Until a stopping criteria is, this process is performed. The stopping criteria for K-means may be the maximum number of iterations, or when there is no change in the newly obtained centroids, we stop the process. Flowchart. First, we start the algorithm. We enter the number of clusters and iterations and randomly choose initial centroid vectors, then calculate the distances and cluster the objects, and when there is no object to move, we'll stop, or if there is an object to move, we'll recalculate the centroids and calculate distances, and this process is performed until the stopping criteria is reached. Here we can see the image for K-means clustering. Advantages of K-means. K-means algorithm appears extensively in the machine literature and in most data mining suite of tools. K-means is more popular because of its ease of interpretation and simplicity of implementation. Speed of convergence and adaptability to spread the data. Disadvantages of K-means. The accuracy of algorithm depends upon selection of initial centroids. There is no particular election algorithm for choosing centroids. The algorithm is sensitive to outliers, where outliers could be errors in the data recording or some special data points with irrelevant values. The K-means algorithm is not suitable for discovering clusters that are not hyperellipsoids or hyperspheres. For the complex multimodal problems, it is always stuck at local optima. The algorithm only achieves the local optimal value. The value of K and number of iterations should be small, otherwise the time and space complexity of the algorithm will become high. This is a major issue of K-means clustering algorithm. Clustering as an optimization problem. Most clustering algorithms are based on two popular techniques known as hierarchical and partitional clustering. In hierarchical clustering, the output is a tree showing a sequence of clustering, with each clustering being a partition of the dataset. Advantages. The number of clusters need not be specified a priori. They are independent of the initial conditions. Disadvantages. They are static, that is, data points assigned to each cluster cannot move to another cluster. They may fail to separate overlapping clusters due to a lack of information about the global shape or size of the clusters. Partition clustering algorithms partition the dataset into a specified number of clusters. These algorithms try to minimize certain criteria and can therefore be treated as optimization problems. The advantages of hierarchical algorithms are the disadvantages of the partitional algorithms and vice versa. Partition clustering techniques are more popular than hierarchical techniques in pattern recognition. Evolutionary based algorithms. The aim of an optimization problem is to determine a best suited solution under a given set of constraints. Mathematically, an optimization problem involves a fitness function which needs to be maximized or minimized. Most of the traditional optimization techniques employ derivative approach to locate the optima. This approach fails to determine the global optima for multi-module optimization problems. More recently, the optimization problem is being represented as an intelligent search problem where one or more agents are employed to determine the optima on a search space. This technique of searching is called as evolutionary based searching. All evolutionary based algorithms follow a single approach for solving an optimization problem. The approach is given below. Initialize the population with particles or vectors. Calculate the fitness function for each particle or vector. Based on the best fitness value, update the position of the particles or vectors. The difference among different evolutionary based algorithms lies in the way they update the particles by changing the parameters. Here the fitness function will be any of the benchmark function. These can be sphere, Rosenberg, Rastrigin, Greenwald, etc. Particle swarm optimization. Introduction to particle swarm optimization. It is an evolutionary computation technique developed by Kenley and Ebert in 1995. They were essentially aimed at reducing computational intelligence by exploiting simple analogs of social interaction rather than purely individual cognitive abilities. Particle, very small group of area. Swarm, a group of moving insects. Optimization, choosing the best solution from the available alternatives. PSO is a robust optimization technique based on the movement and intelligence of swarms and involved analogs of bird flocks, search and Foucault. These soon developed into a powerful optimization method, PSO. In PSO, new samples are generated by perturbation of existing solutions. Later approach can lead to issues of stability. Original process for implementing PSO. Initialization of particles, evaluating fitness function, comparing the p-best value and updating g-best values by comparison, and changing the velocities. Fundamentals of PSO. PSO is a population-based search algorithm and is initiated with a population of random solutions called particles. In this, each individual is treated as a volume-less particle in a d-dimensional search space. The ith particle is represented as xi is equals to xi1, xi2, up to so on xid. The best previous position, that is the position giving the best fitness value of the ith particle, is recorded as pi is equals to pi1, pi2, up to so on pid. The index of the best particle among all the particles in the population is represented by the symbol g. The rate of position change, that is velocity, for particle I is represented as vi is equals to vi1, vi2, up to so on vig. The particle is manipulated according to the following equation. Vid is equal to Vid into W plus C1 into random into PID minus XID plus C2 into random into PGD minus XGD, and XID is equals to XID plus VID, where VID represents velocity, XID represents particle's position, PID is local best, PGD is global best, and W is inertia of flight, C1, C2 are constants, and random is a random function within a range of 0, 1. PSO clustering algorithm. There are different versions of PSO models. Here we use the basic PSO model called GBus model, wherein every particle will interact with every other particle to decide its optimum direction. Data vectors can be clustered using standard GBus PSO as follows. Randomly select nk cluster centroids to initialize each particle. For I equal to 1 to I max, do. For each particle I, do. For each data vector Zp, calculate Euclidean distance for Zp and Aq to all cluster centroids Ck. Assign ZP to the cluster CQs such that if the distance is minimum, and calculate the fitness using the equation. Update the GBEST and PBEST positions. Update particle positions and velocities using the above equations, where Imax is the number of iterations. Flowchart for PSO. Here we can see the start and then initialize the particles with random positions and velocity vectors randomly, and for each particle P, evaluate the fitness function, and if the fitness value is less than the fitness of PBEST, then PBEST is equals to P. Set best of PBEST as GBEST, and update the best positions with equation 1 and corresponding velocities with equation 2. Giving GBEST as optimal solution, and then stop. Here we can see a figure representing birds, and each bird has its PBEST value, and from all the PBEST, the best value is taken as the GBEST value. Advantages of PSO. PSO is very simple to implement and easy to understand. PSO uses fewer parameters when comparing with the similar algorithms like differential evolution and genetic algorithms. PSO gets best results in faster and cheaper way compared with other methods. PSO applications are used for solving the complex problems like economic dispatch. Application. It has a wide range of applications like telecommunications, data mining, power systems, signal processing, function optimization, artificial neural network training, fuzzy system control, where genetic algorithm can be applied. In artificial neural network, it can be trained in using MATLAB, and signal processing we can use digital signal processing, and in data mining we have implemented this algorithm. Future enhancements can be done by hybridization of k-means and PSO, and we can also implement k-means and PSO in MATLAB, and hybridization of PSO and DE using the parallel algorithms can also be done. Conclusion. Finally, we conclude the basic particle swarm optimization algorithm by geometrical mathematical explanation of PSO, particles movement and the velocity update in the search space, the acceleration coefficient, and particles neighborhood topologies. Thank you.